You saw in the video that you watched yesterday that if you dump a strong acid and a strong base together, it actually makes a solution that has a pH of 7. It actually becomes neutral. And so whenever you mix an acid and a base together, you have what's called a neutralization reaction. And so what that looks like, I mean, the example that he gave you, that he did in the video, was he took hydrochloric acid and he mixed that with sodium hydroxide. And what this really is it is a double replacement reaction. This is the same kind of reaction that you actually learned about back in chapter 5 when we talked about different types of reactions. And we said it's sort of like dance partners where they just swap partners. The only thing that you have to watch in this one, because we didn't really deal with things like OH, the OH, what you just have to remember is it's going to kind of stick together as one of the partners. So the H is partnered with the Cl and the A is partnered with the OH. And so if they swap partners, the hydrogen is positive, just like we learned before. We learned that the sodium is positive. And so if those two positive things are going to switch places, then I'm going to end up with the Na with the Cl over here on this side. And I'm going to have the H that's going to end up with the OH. And if I have an H and an OH together, that's the same as H2O. It's the same as water. So the overall general formula for a neutralization reaction is that I'm going to take an acid plus a base, and that's going to give me, now this is NaCl, this actually is table salt, but anytime that I have a metal with a non-metal, it is called a salt, whether it's table salt or not. So I could have something like potassium and chlorine together. I could have sodium and bromine together. I could have beryllium and oxygen together. And so if it's a metal and a non-metal and I put them together, it's called a salt. So an acid plus a base makes a salt and water every single time, okay? Now, if I have a strong acid and a strong base, it does make a neutral solution. The other thing that he showed you, though, was where he was showing you a buffer solution. And a buffer solution it can get into some pretty complicated chemistry that even if you take a year of chemistry in high school, you may not talk about buffers. But we're going to just very briefly touch on buffers because our body uses them all the time. He was showing you what happens if he has this solution and he dumps lemonade in it. And then he said, well, what happens if he takes this solution that's actually what's called a buffer solution and he dumps lemonade in it? That buffer solution resists a change in pH because what happens is that you have both a weak acid and a weak base in this buffer solution. And so if you dump in an acid, then the base will react with it. If you dump in a base, then the acid will react with it. And so what happens is that you've got that weak acid and that weak base in there will react with whatever you put in it, and it will resist a change in pH, which thankfully is really good for us because our creator knew that our pH was going to have to stay within a very, very narrow range for us to be healthy and functioning and alive. And so he equipped our bodies with a buffer system so that even though we enjoy eating all these acidic things like tomatoes and grapefruit and drinking or using vinegar on our salads, we've got a way to deal with that in our bodies. We produce a base, but then we also have this buffer system so that we can handle the acids and the bases as well that we're going to put in our bodies as we're feeding our bodies. Okay, so while it's a pretty complicated concept as to how a buffer actually works, the part about a buffer that I want you to understand is that a buffer is made up of both a weak acid and a weak base, and so then that will neutralize whatever else you put in it, and the pH will not change very much, okay? because of the neutralization reactions that are going on. And again, those reactions between some of those weak acids and weak bases are way beyond what we're going to do in physical science. But I do want you to be able to do some simpler neutralization reactions. So I'm going to do a couple of examples. And if you don't have a piece of paper, you might want to grab one so that you can practice balancing those, predicting what the products are going to be as I do them with you. So we've done a really simple one up here, but now we're going to do a couple that are just slightly more complicated. Let's say that I'm going to take hydrochloric acid again, but this time I'm going to react it with magnesium hydroxide. And so magnesium hydroxide looks like this. Now, you haven't seen a lot that looks like this before, but when we started talking about different chemical formulas, we said we know that the charges have to be balanced. And so we were looking at the periodic table to determine what the charges were of these different types of things. We know from the periodic table that since hydrogen is in the first column, that it tends to have a positive 1 charge. So I'm just going to write that down here really little. We know that chlorine, being in the second to the last column, we know that it tends to have a negative 1 charge. So I need 1 of each in order to balance that out. Remember doing that, I hope. Okay, if you look at the periodic table, where is magnesium on the periodic table? Flip to the back of your book and see if you can find magnesium on the periodic table. And where is it located? Hopefully you'll see that it is in the second column. And so that means that magnesium has a positive 2 charge. Anytime you see this hydroxide, which we said is very, very characteristic of a base, that hydroxide is going to have a -1 charge. And so since this has a positive 2 and the hydroxide is a -1, when I lump those together and it has a -1 charge, I have to have 2 of these in order to balance out this positive 2 on the magnesium. So that's why I put the hydroxide in parentheses, and then I put a 2 on the outside of it to show that I'm going to have 1 magnesium, but I need 2 of these hydroxide groups. If I wrote it like this means that I have 1 oxygen and 2 hydrogens, but that's really not what I mean. What I mean is that I need 2 of these hydroxide groups. So if you need more than 1 hydroxide group, you have to make sure that you put parentheses around it. Okay, so here's our acid, here's our base. Now, when we react this together, we're going to end up with a salt and with water. So what salt am I going to end up with here? Well, if I take the metal from here and the non-metal from over here, so the positive ion from this one and the negative ion from this one, to do my dance and to swap my partners, the positives and the negatives always have to go together. So I'm going to put the magnesium and the chlorine together. Now, what is this formula going to look like? Well, like we just already said, the magnesium has a positive 2 charge because of where it is on the periodic table, and the chlorine has a -1. So what do I have to do to make that balance? Hopefully you said I need to have 2 of these in order to make my charges balance. So MgCl2. Do you remember what that's called? Hopefully you remember it's called magnesium chloride with an IDE on the end. Okay, so this is one of my products. The other product I already know is going to be water. And I can see that it's going to be water because since I've swapped partners and I've used these 2 already, I'm going to take the H and I'm going to take the OH and I'm going to put those together to make water. Okay, so those are the products. Now I have to be sure that my equation is balanced. So if I look here, I would recommend that you start with something besides the hydrogen and the oxygen because that gets a little more tricky. It's not hard, but it just is a little bit more tricky in order to see it. So let's start with the other part first. My magnesium is balanced right now, but my chlorine is not. Here I have 2 chlorines and here I have only 1. Now remember, when we balance an equation, it has to go in front. I can't add any more subscripts. I can't just stick a 2 down there. That's illegal because then these charges won't be balanced anymore. So if I have 2 chlorines over here, that means I have to have 2 HCl's over here. Okay, so now my magnesiums and my chlorines are all balanced. And how about my hydrogens and my oxygens? Well, I have 2 hydrogens that are going to combine to mix with 2 hydroxides. Now, what you can do, if it makes it easier, is you can write this as HOH, because it makes it a little bit easier to see that, if I use a colored marker so you can see it, here's the H, and then here's the OH. So if you want to write it as HOH and it's easier for you to see it that way, I'm perfectly fine with that. So I have 2 of these and I have 2 of these. So what that means is that I need 2 of the HOHs, or 2 waters. Again, whichever way you write it doesn't make any difference to me as long as you understand where it's coming from. Okay, so there's our balanced equation. Everything's now balanced. An acid plus a base yields a salt plus water. Let's do one more to make sure that you understand the process here. Okay, let's say that I'm going to start with HBr this time. That would be called hydrogen bromide or hydrobromic acid. And let's combine that with aluminum hydroxide. Now, if you recall from the periodic table, aluminum is over on the right-hand side, but it's in that column where we said that that's going to have a +3 charge. So this is a +3. I'm just writing it down there just so I can remember it. You don't have to write the charges down there. Remember that hydroxide is always going to have a -1, and that's why I have 3 of them to balance out this +3 charge on the aluminum. The hydrogen's always a +1. The bromine is in the second to the last column. It's in the same column as the chlorine is, and so it's going to have a -1 charge on it. Okay, so here's my acid plus my base. So why don't you pause the video for just a second and see if you can come up with the products that we're going to have, and I'll be right here when you get back. All right, what did you come up with? So what you're going to have to do is you're going to have to combine the positive ion from the base with the negative ion from the acid. So that means the aluminum and the bromine are going to go together like this. Now, is that the right formula? It is not, because aluminum is a +3 and bromine is a -1, and so those aren't balanced that way. So what do I have to do to make them balance? Yeah, I have to have 3 bromines in order to make that balance, okay? What's my other product over here? Well, my other product, because an acid plus a base yields a salt and water. So I'm going to have H2O, and again, if you want to write that as HOH because it's easier for you to get the equation balanced, I'm okay with that. All right, so let's check the, do everything but the hydrogen and oxygen first. So let's check the bromine. I have 1 bromine on this side, but I have 3 over here. Remember, you can't just stick a 3 down there, you have to stick it in the front. So I'm going to have 3 bromines on this side. I have 1 aluminum on each side, so that's already balanced, so I don't have to do anything else there. And again, I'm going to mark this just so that it's a little easier for you to see. The hydrogen comes from there, and the hydroxide comes from over here. So I have how many hydrogens? I have 3. How many hydroxides do I have? I have 3 of those too. So how many waters does that mean I'm going to have? Well, if I have 3 of each, that means I'm going to have 3 waters. Or if you write it with the HOH, you have a 3 up there, okay? Pick one or the other of these. Don't use both. I'm putting both of them on there so you can see it, but when you write it, either write 3H2O or write 3HOH. Don't write both of them. Just pick one or the other, okay? So I will give you some practice today in balancing some of these equations yourself. Just remember that you're going to take the positive ion from the base and the negative ion from the acid, and you're going to put them together, and then your H and your OH are going to go together to make water.